Hello guys, are you ready for our next lesson? For our lesson for today to be discussed is all about sequences and series. Okay, so our learning competencies states here we are going to illustrate series and then differentiate series from sequence. Okay, so as we start, let's have the very first one, which is the sequences. Okay, how will we define sequence? Sequence is said to be a list of objects or events or numbers in a definite order or of occurrence. And did you know that when you say sequence in other textbooks, it is called also as progression. So if we have here an example of uh, 2, 4, 6, 8, this is said to be a list of numbers that is said to be in a definite order. Okay, other examples we have 1, 5, 9, 13, 17, 21, and so on. And then of course the last example here is 1, 3, 9, 27. Okay, and of course each member of the sequence is called now a term. Okay, so there you have. Again, this is the definition of the sequence or a progression. And we could classify sequence into two. The first classification is either a finite sequence. When we say a finite sequence, it contains finite number of terms. So for example, 2, 4, 6, 8. So that is finite because there is an exact number, okay, or limited number of sequence. 1, 5, 9, 13, 17, 21, and so on, up to 37. So again, that is still considered as a finite sequence because the ellipsis there is considered as that's not containing the last term, but instead the last term there is up to 37. So again, finite sequence contains the finite number of terms, and as a reverse, we have here an infinite sequence. So when we say infinite sequence, it is said to be having an infinite number of terms. Thus, the last term is not indicated. So as example here, we have 2, 4, 8, 16, 32, and so on. The ellipsis there indicates now that the last term does not what? Identified, because it is said to be infinite. Another example, we have 1, 3, 9, 27. Of course, the ellipsis there denotes us that it's indicating now an unlimited term. Okay, so the notation a sub n represents the nth term of the general term of the sequence. Okay, and let's have the very first type of sequence. Okay, the first one is arithmetic sequence. When you say arithmetic sequence, a sequence in which the difference between two successive terms is constant. We have here an example. We have 5, 10, 15, 20, and 25. As we'll observe, if you are going to get the difference of the two successive terms, 10 and 5, the difference there is 5, 15 and 10 is 5 again, 20 and 15 it's 5, and then of course 25 and 20, the difference there is we have 5. So D there is called, it's 5, and this difference or D denoted is called now your common difference. Okay? And one more thing to consider when we have the arithmetic sequence or sequences, we have here 3, 7, 11, 15, and 19. The first and then the last term is called now your arithmetic extremes. First and the last term is called now your arithmetic extremes. And of course, the in-between terms from 7, 11, and 15, this is now called your arithmetic means. Okay? So as another example here, you are asked to write the first 5 terms of the arithmetic sequence whose first term is 4 and whose common difference is 7. So a sub 1 represent now your first term, which is 4, and then of course the common difference from the first term is 7. So we simply, for the second term, we add 7. So there you have, it's 11 for the second term, and then from 11 you're going to add 7 again, it's 18, and then from 18 you add 7, it's 25, and then of course from 25 plus 7 it's 32. So therefore, the first 5 terms are 4, 11, 18, 25, and 32. Okay? And of course, another concept on arithmetic sequence is in which a sub n is the general term, a sub 1 is the first term, and n is denoted as your positive integer. We could use this as a formula. We have a sub n is equals to a sub 1 plus quantity n minus 1 times d. Again, your a sub n there denotes the general term. A sub 1 is your first term, n is a positive integer, and d there is your common difference. Some other, when we derive another formula, there you have to be used in our succeeding lessons. Okay? You are to find the 11th term of the sequence, 12, 15, 18, and 21. Okay? So the first thing to consider is determine your common difference of 15 and 12, or 18 minus 15, okay, or 21 and 18. Okay, so therefore, we have the common difference is 3. So from our formula a while ago, we have a sub n equals a sub 1 plus quantity n minus 1 times d. Okay, all we need to do therefore is we simply substitute from the given. Your a sub 1 there is 12. Your n is therefore 11 because it's 11th term. And then of course your d is simply it's 3. So there you have. Okay. So we simplify it further. 11 minus 3, it's 10. Okay, times 3. So it's 30 plus 12. So therefore we have 42. So the 11th term of this sequence is simply 42. Okay, so that is all about arithmetic sequence. Okay, let's proceed with the second sequence. It is called now your geometric sequence. Okay, so when we say geometric sequence, it is said to be a sequence in which the ratio of any two consecutive terms is constant. This constant is called now the common ratio, which is denoted by R. As an example here is 5, 10, 20, 40, and 80. So when we see common ratio, we are going to divide the second term to the first term, or third to the second, or fourth to the third, or fifth to the fourth, and so on. From the word there, any two consecutive terms. Okay, so let's try 10 and 5. So we have 2, 20 and 10, it's 2, 40 and 20, it's 2, and 80 and over 40 is 2. So therefore, our R is denoted by what? It's 2. The common ratio there is 2. Okay? Now, as an example here, you are asked to write the first 5 terms of a geometric sequence whose first term is 2 and whose common ratio is 6. Okay? So again, your a sub 1 is 2. Then the common ratio is 6, so we simply multiply the first term with 6. So therefore, the second term is 12. And then this 12 now is to be multiplied by 6 again, so we have 72. From 72 multiplied by 6, and we have 432. And then of course, the last term that we are asked is the fifth term. 432 times 6, it's simply 2,592. So therefore, we conclude that the first 5 terms are 2, 12, 72, 432, and 2,592. Okay? Another thing to consider for geometric sequence is that the nth term of a geometric sequence is, we could use this formula, a sub n is equals to a sub 1 times r raised to n minus 1. And we could derive other formula out of this. There you have. Okay? And for our example here is you are asked to determine the 9th term of the sequence. Okay? So without the formula, 3, 9, 27, 81, 243, if you are going to do it manually, okay, it would be time consuming. But because of our formula, a sub n is equals to a sub 1 times r raised to n sub 1. All we need to do therefore here is to identify first our r. So 9 over 3, okay, 9 over 3 or 27 over 9, 81 over 27, 243 over 81. So our r there is simply it's 3. So from our formula, a sub n equals a sub 1 times r raised to n minus 1. Substitute. Therefore, your a sub 1 there is 3, your r there is 3, then n is 9 minus 1. So simplify further. We have there 3 quantity 3 raised to 8. So therefore, 3 raised to 8 is 6,561 times 3. So we have 19,683 as our ninth term. So again, the ninth term there is 19,683. So that is all about geometric sequence. Now let's move to our next type of sequence, and that is now called your harmonic sequence. When we say harmonic sequence, it is said to be a sequence formed by the reciprocals of the terms of an arithmetic sequence. So therefore, with this third type of sequence, we should have mastered the concept on arithmetic sequence, because their only difference is it's just a matter of your reciprocal. Okay? So the sequence S sub 1, S sub 2, and so on until S sub n is said to be a harmonic sequence if and only if we have 1 over S sub 1, 1 over S sub 2, and so on. We have 1 over S sub n forms an arithmetic sequence. So for example here, 1, 1 half, 1 third, 1 fourth. So let's convert that first in an arithmetic sequence by, of course, if that is the reciprocal, we get the reciprocal again of that. So 1 and then 1 half, 1 third, 1 fourth. So simply we have 1, 2, 3, and 4. So what you observe, it forms an arithmetic sequence. So therefore, we could classify the first one, 1, 1 half, 1 third, and 1 fourth as a harmonic sequence. Because what? From our consideration there, it satisfies that is now a harmonic sequence because it forms an arithmetic sequence. Okay, let's try another one. To find the nth term of a harmonic sequence, first write the corresponding arithmetic sequence. Second, determine the nth term of the arithmetic sequence. Then lastly, take its reciprocal. You are asked here for the 50th term of the harmonic sequence. 1 half, 1 over 9, 1 over 16, and 1 over 23. So from there, you are asked for the 50th term. So again, if we don't have the formula, what do you observe? If we are going to use manual, it would take time for us to compute for the 50th term. How about if it's 100th term or and so on, if it's bigger term? Okay, so again, from the first steps, we are going to convert first in an arithmetic sequence. So your 1 half is 2, your 1 over 9 is 9, 1 over 16 is 16, 1 over 23 is 23. Okay, get the reciprocate it first, and then of course, what will be the common difference? 9 minus 2, 16 minus 9, 23 minus 16. Okay, so from our formula for arithmetic sequence, we have a sub 1 plus quantity n minus 1 times d. Your a sub 1 there is 2. Then of course, your term there is 50 minus 1, and our common difference is simply it's 7. Okay, so therefore, as we simplify it further, 49 times 7 is 343 times 2. So therefore, our 50th term is what? 1 over 345, because we do not stop there with 345 because we need to take its reciprocal. So therefore, from our 50th term of this harmonic sequence, it's simply 1 over 345. Okay, that is for harmonic sequence. And then lastly, we come up with the last type of a sequence that we are to deal with, and that is now called your Fibonacci sequence. When you say Fibonacci sequence, it is a sequence of numbers in which each number in the sequence is equal to the sum of two numbers before it. Okay, so the sequence of numbers, we have f of n is defined using the recursive relation with the seed values. F sub 0 is equals to 0 and f sub 1 is equals to 1. So therefore, for Fibonacci sequence, we are going to start with f sub 0, which is 0, and f sub 1, which is 1. So it starts with 0 and 1. From the definition, each number in the sequence is equal to the sum of two numbers before it. So before we come up with the third term, you simply add 0 and 1. So there you have 0 and 1. We have still 1 for the third term. Okay, how did we arrive with the fourth term? We simply add a 1 and 1. Okay, so we have 2. Then again, how did we arrive with 3 for the next term? 1 plus 2. Okay, and then again, we have 3. How did we arrive with this term, which is 5? 2 and 3, which is 5. Then again, how did we arrive with 8? 3 and 5. How did we arrive with 13? 5 and 8. How did we arrive with 21? 8 and 13. So therefore, what will be the next term for 21? So simply it's what? 13 and 21. So therefore, we have 34. So that is for Fibonacci sequence. It's just a matter of what? Adding the two numbers before that term. So we have 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. So that is all about Fibonacci sequence. We are through with the sequences from arithmetic, geometric, harmonic, and Fibonacci. We are now ready for the second part, which is all about what? Yes, it's all about series. Now, when we say series, guys, okay, from the definition here, series is said to be a sum of the terms of a sequence. So what's the difference between a sequence and a series? So let's try to compare. When you say sequence, we have 2, 4, 6, 8. Okay, but you notice in series, that is now a sum of the terms. So therefore, instead of comma, we are going to use now a plus sign, a plus symbol. So we have 2 plus 4 plus 6 plus 8. This is now a series. But on the first example, 2, 4, 6, 8, it's just a mere sequence. So again, the identity for series, we are going to get the sum of the terms of that sequence. And the same true with sequence. There are two classifications of series, and that is for finite series. Okay, so when we say finite series, okay, it is said to be what? Sum of a finite number of terms. So from the given exact number of terms, it's just a matter of adding it. So again, we have 5, 10, 20, 40. So therefore, in series, 5 plus 10 plus 20 plus 40 equals 75. So that is for finite series. We simply add the finite number of terms. Of course, the second classification is infinite. Sum of all the terms in the sequence. Okay, so we have 2 plus 4, 2, 4, 6, 8 for sequence. For series is simply 2 plus 4 plus 6 plus 8 plus n, and so on. Okay, so that denotes now an infinite series. Okay, we have 5, 10, 20, 40. For series, we have 5 plus 10 plus 20 plus 40 plus n. Okay, so now, what do you notice here, guys? Okay, when the general term of a sequence is known, the summation notation is used for denoting a sequence. The Greek uppercase letter sigma is used to mean sum. Okay, so for infinite series, we are going to use this summation notation. Okay, so again, this is a capital letter for sigma, Greek letter sigma, which means sum. Now, how do we read this one? Okay, we have here the sum of the quantity 2n minus 1 as n goes from 1 to 3. Okay, now this is our general term, and there denotes now for your what? Your index of summation. Some other textbooks, they are using, instead of n, they are using I. Okay, so we have here, okay, so that is now your index of summation. So again, we have the sum of your quantity 2i minus 1 as I goes from 1 to 3. So meaning, if you are going to illustrate that, substitute your I with 1 until you substitute to 3. Okay, so as you notice here, so 1 is the starting point, okay, then followed by 2, followed by 3. So 2 times 1 is simply 1 minus 1, okay, and then 2 times 2 is 4, Okay, minus 1. Then 2 times 3 is 6 minus 1. So therefore, we have 1 plus 3 plus 5. Then, therefore, the summation of your quantity 2i minus 1 as I goes from I to 3 is equals to 9. Let's have other examples here. Okay, we are asked here to get the sum of the your general term is n squared plus 2 as I goes from 0 to 5. So what do you do again? Your n here is to be substituted with 0, 1, 2, 3, 4, and 5. Okay, so there you have. Okay, so again, it's just a matter of substitution. Then of course, after substituting it, get the simplify it further. So from there, we have 2 plus 3 plus 6 plus 11 plus 18 plus 27. So our final answer there is simply it's 67. So again, the summation of our expression n squared plus 2 as I goes from 0 to 5 is simply 67. Okay. Now, let's have these partial sums. When you see partial sums, the sum of the first n terms of a sequence is a finite series known as your partial sum, which is denoted as S of n. So, partial sums is for finite series. So, we have the S sub 1 equals A sub 1, S sub 2 is equals to the two terms, A1 and A sub 2. The same true with S sub 3, your partial sum, which is now you are going to add 3 terms. Okay, so in general, S sub n is the sum of the first n terms of a sequence. So therefore, we have here a notation, S sub n is equals to the summation of your A sub n as I goes from 1 to n. Let's try an example. Okay, you are going to write the series using summation notation. 4 plus 10 plus 16 plus 22 plus 28. Okay, so with that, since the difference of each term and the preceding term is 6, so 10 and 4, 16 and 10, 22 and 16, 28 and 22, the common difference there is 6, okay, and our first term there is 4, okay, so from our formula of our arithmetic sequence, if you still recall, okay, we have A sub 1 here denoted as 4. Of course, n is what? How many you could observe here? 1, 2, 3, 4, 5. But of course, we have to write there 5. And instead, just as it is. And then of course, your D here is 6. So 4 plus quantity n minus 1 times 6. We simplify it further. Okay. So, as we simplify it further, it's just a matter of distribute your value of 6 here. We have 6n minus 1. So, simply 6 times n, 6n, 6 minus times negative 1 is negative 6. Arrange it. Simplify it further. 4 minus 6 is negative 2. So, therefore, 6n minus 2. This is now our summation notation of 4 plus 10 plus 16 plus 22 plus 28. Okay? So, therefore, the summation, okay, the summation of 6i minus 2 as I goes from 1 to 5. This is now our summation notation. Okay, let's try another example. Write the series using summation notation 3 plus 9, 27, 81, 243. Now, what do you observe? Okay, is this an arithmetic sequence? Is this a geometric sequence? You will observe there, okay, it's a product. Okay, preceding term and that is 3, so therefore it's a geometric sequence. Your first term is 3, and our R is simply it's 3 also because 9 over 3, 27 over 9, 81 over 27, 243 over 81. We simply have your common ratio is 3. Okay, so from our formula for geometric sequence, we have A sub n equals A sub 1 times R raised to n minus 1. So your first term is 3, your r there is 3. So there you have it. Okay, after that, as we simplify it further, okay, so we have 3 raised to 1 times 3 raised to n minus 1. We are going to extract your common base, which is 3. Okay, so there you have 1 plus quantity n minus 1. Simplifying it further, we have 3 raised to n. Okay, so 3 plus n plus 9 plus 27 plus 81 plus 243 is simply the summation notation there is 3n. Okay, or again, we are going to replace n with I. So the summation of 3i as I goes from 1 to 5. Okay, so again, the question, maybe your question is, how do we know if it's an arithmetic sequence or if it's a geometric sequence? If you're going to subtract 9 minus 3, okay, we have 6. If you subtract 27 and 9, so again, it's not the same. So therefore, why not try another type of sequence? It is now your geometric sequence with common ratio, which is 3. Okay, now another example. Find the sum of the first 4 terms of the sequence whose general term is a sub n equals 5 minus n all over 3n. Okay, first 4 terms. Okay, so if we are going to represent that, there you have it. S of 4 is equals to the sum of 5 minus I over 3I as I goes from 1 to 4. Because take note, find the sum of the first 4 terms. So your starting point now there is 1, and then of course your I there, or index of summation last, is 4. Okay, so there you have. It's just a matter of substitution once again. 5 minus 1 over 3 times 1, okay, and so on. Okay, as we simplify it further, we have 4 thirds plus 3 over 6 plus 2 over 9 plus 1 over 12. Okay, take note, we have different denominators, 3, 6, 9, and 12. So get the LCD, and that is 36. Okay, there you have it. And then as we simplify it further, we have 77 over 36, or simply our summation of the first 4 terms of the sequence with the general term. We have a sub n equals 5 minus n all over 3, and is simply 77 over 36, or a mixed fraction, which is 2 and 5 over 36. Okay, let's proceed with the other types of series, which is the arithmetic series. S of n of the first n terms of an arithmetic sequence is given by, okay, there you have the formula. S of n equals n over 2 quantity a1 plus a sub n. Again, what does your variables denotes there? S stands for the series, n for the positive integer, or your terms of your sequence. A sub 1 is the first term, a sub n is the last term. Okay, there you have it. Let's have an example. Find the sum of the first 4 terms of the arithmetic sequence, which is 3, 9, 15, 21, and 27. Okay, we identify our common difference, 9 and 3, 15 and 9, 21 and 15, 27 and 21. So therefore, we have simply it's 6. Okay, so first 4 terms. So our n there from our formula, S of n equals n over 2 quantity a sub 1 plus a sub n. So n is 4 because from our first 4 terms. Then a sub 1 is 3. Then of course a sub n, 4 terms, 4. So therefore 1, 2, 3, 4. We have 21. Okay, so why is it not 27? Because from there is our first 4 terms. 1, 2, 3, 4. The fourth term is 21. So 3 and 21 are just the involved terms there. So simplify it further. 24 times 2. So therefore, the sum of your first 4 terms is 48. You could check that. 3 plus 9 plus 15 plus 21. The summation of that is 48. Okay, let's have another example. Find the sum of the first 25 even integers. So if you're going to work it manually, 25 even integers, it's too long. So from the formula, okay, even integers 2, 4, 6, 8, and so on until you reach 50. Okay, why until 50? Because that's the 25 even integers. So it's an arithmetic sequence, and the formula for that is again S of n. And we are going to use n equals 25, a sub 1 is 2, and of course, our last term, or a sub n, is equals to 50. Okay, so there you have from the formula, 25 over 2, quantity 2 plus 50. Okay, so 25 over 2 times 52, and it's simply 650. So the sum of the first 25 integers, even integers, is 650. Okay guys, let's proceed. That is an arithmetic series. Let's proceed now with a geometric series. When you see geometric series, guys, S of n of the first n terms of a geometric sequence is given by this formula. Okay, we have S of n equals a sub 1, quantity 1 minus r raised to n all over 1 minus r. 1 there is a constant, and see to it that r should not be equals to 1. Okay, a sub 1 is the first term. R is your common ratio. Okay, let's have an example. Our example here is to find the sum of the first 5 terms of the geometric sequence. 3, 12, 48, 192, 768, 3072, and so on. Again, first 5 terms. So 1, 2, 3, 4, 5. Okay, first 5 terms. So you could add it manually, but of course from our formula, okay, a sub 1 is 3, and then our ratio, 12 over 3, or 48 over 12, 192 over 48, and so on. Our r there is simply it's 4. Okay, so from the we simply substitute. Therefore our n is 5 because we are asked there for 5 terms. So 1 minus 4 raised to 5. Okay, and then of course simplify it further. 3 times quantity 1 minus 1024 over negative 3. Okay, so there you have. And final answer is 1023. Okay, so the sum of the first 5 terms of your geometric sequence is 1023. Okay, so that is all about for geometric series. Now, let's generalize, sum up our lesson as for these sequences and series. We have there the sequence. Again, take note if we are going to compare sequence from series. Sequence is said to be succession of numbers in a specific order, and it forms some fixed rule or property. On the other hand, when you say series, it is said to be the sum of the terms of your sequence. And for your different types of sequence, arithmetic sequence, which of course denotes us with the common difference. Geometric sequence denotes us with the common ratio. Harmonic sequence now, okay, it's just a matter of getting the reciprocal of the arithmetic sequence. And for your Fibonacci sequence, all we need to do is to add the numbers before that term. 2 numbers before that term. Okay, and for the series, we have learned 2 types also, which is the arithmetic series and of course your geometric series. So in general, a series is the indicated sum of the terms in a sequence, but instead of writing down all the terms, we can use a more concise way to express this sum, which is called now your summation notation. Okay, so that's for it, guys. Thank you for listening and hoping you have learned something today. And of course, remember this, handang isip, handa bukas, tara na, ML na tayo. Okay? And again, guys, thank you for your time, for listening, and again, hoping to see you again on our next lesson. And of course, do not forget to subscribe to our channel and like our videos. Thank you, guys.